Welcome to the Planet on the Move podcast. I'm your host Anindita, and today I'm joined by Professor Michael Steckler. Professor Steckler, thank you so much for being my first guest on the podcast.
My pleasure.
So I would like to start by saying that how I first met you during the Bangladesh class at the Art Institute, but I don't think I ever told you, but I have seen your name every time there had been an earthquake in Sylhet. So following your 2016 research that got published, I think every news article was citing your name, saying that your research is predicting a high magnitude earthquake. So 7 years after that research, does that still hold true?
It still holds that there is the potential for a large earthquake, but further research has shown that the magnitude is probably less than we said in the 2016 paper, probably towards the lower end of the range that we put out. And part of that is, in 2016, we were uncertain about whether a fault system in Myanmar called the Kabul fault system was active or not. And since then, we put instruments, GPS instruments in Myanmar and show that it is active, and therefore the thrust that's beneath Bangladesh, the motion is less.
Okay, so it still has a potential for high magnitude, but less than 9, that was predicted before.
Right, probably closer to an 8, but which is still quite substantial.
Mm-hmm. And I remember when that research got published and all the newspapers were like citing that, and I also remember like there were mixed reactions. So we as people were very anxious that Sylhet is kind of the epicenter. And then politicians were very dismissive, and I think like in generally that the liaison between government and scientists is not always a great one. So how did you reconcile with that, and how do you
I think there was a tendency for both the politicians and the scientists to try to minimize the impact. I mean, one question is we don't know if that earthquake would happen soon or not for another 500 years. But a lot of people were panicking over it. And so I also know a number of geologists who wrote articles trying to minimize the risk and calm people down. The problem is, if people are panicked, nothing happens to help the situation. If people ignore it, nothing happens. But getting that point where people are concerned and take action but aren't panicking is very difficult to reach.
Yeah, that's very true, because I think right after that every schools and like offices started giving instructions on how to like mitigate the risk of earthquake and where should we go and protect ourselves. Yeah. So now that we have talked a little bit about the future and what that looks like, that the hazard's been a little less, I'd just like to go a little bit to the past. And I think before your paper I did not hear about the Dauki fault that exists in Sylhet, or about like the earthquake risk. So what was your journey like going to Sylhet, and how did you find out about the faults, and just tell us about your journey.
Sure. When I first started going to Bangladesh, I was interested in the tectonics, but also didn't know very much about it, and slowly learned. So in the Shillong Plateau area of just north of Bangladesh, there was a major earthquake in 1897. And for instance, to the south of Bangladesh, from Chittagong south along the Arakan coast, there was a major earthquake in 1762. But the area between those, between Chittagong and Sylhet, there is no historical earthquake. And so the question is it an area that doesn't have large earthquakes, or is it one to be expected? And so we started, working there to try and determine that.
Yeah, I also think something that I was I really liked from your class was that how culturally aware you were about the history of Bangladesh, the culture of Bangladesh, and I was just wondering, how did you incorporate the local techniques into your measuring system, or if you have, and how did you become so culturally aware?
A lot of my research over the years have been international, and I've in fact worked in a lot of Muslim countries, including Egypt and Turkey, as well as parts of the Mediterranean and Mexico. And so you learn to be a bit more culturally aware. And so early on, I read a lot about the history of Bangladesh and the culture, and has slowly learned about it. In fact, we've done things like incorporated tube well drilling into our research to learn about the sediments as a very, for us, inexpensive way of getting the stratigraphy of the sediments throughout Bangladesh.
And when you mention well drilling, is it more like how we have the tube well system? And
Yeah.
Okay.
Yeah, so very much the tube well system and collecting samples of the sediments as they come up.
Okay, and then you can take them to a lab for measurement.
Right.
Okay. And you mentioned Turkey before, and we have just seen that there was a major earthquake in Turkey recently. And so, how do the faults in that region compare to the faults and the earthquakes that we might expect in Sylhet?
Yeah. Well, the earthquakes in Turkey are a major strike slip earthquake, so more like the San Andreas, where things are sliding past each other. And one good thing in Turkey is that there's a very long historical record dating back to the Romans, so there's a better understanding of how frequently the earthquakes come and where earthquakes might be expected. Whereas in Bangladesh, we don't have that kind of long record. In Bangladesh, is more of a subduction zone, where one plate goes under the other, which is what you see around a lot of the Pacific Ocean. But most subduction zones are underwater.
Okay.
So it makes it hard to study. In Bangladesh, there is so much sediments from the delta that it's actually built the land above sea level. So it's the only subduction zone in the world that sits above sea level, where we can look at the very frontal part of it easily.
And I think I was also wondering, when you mentioned that a lot of the subduction zone, Bangladesh is the only place where you can see it because of the sediments. And would like sediment erosion contribute to measurement issues in the future with like climate change and all that happening in the country?
Well, I also spend a lot of time looking at the delta and the sinking of the land and changes in sea level, and trying to understand the dynamics of the delta as well as the tectonics and how the two interact with each other.
And also, like, because of your trip to Sylhet, I'm sure you have visited the tea gardens.
Yes.
And how was that experience like? And did you use any part of tea gardens for your like research, or if you incorporated that part?
Yeah, we have deployed some of our seismometers in tea gardens, and as well as use them because of the hills, where sometimes we can get a better outcrop to see the rocks. But yeah, I like going up to Sylhet and this tea gardens. Last year we did some magnetotelluric measurements of using electromagnetism to try to look at the thickness of the sediments. And there was one tea garden we deployed in that was just really beautiful.
And do you remember the name of the tea garden?
No, I don't.
But I did pick up something from your blogs about your tea gardens visit, where I think related to that you're trying to put cables under the soil, and there are problems with ruts and rains. And how do you solve that?
We tried a number of different things, because we have to lay out long wires with electrodes at the end, and we find either rats or foxes would eat the cables. And in the end, what we ended up doing was burying the cables.
So under like the tea garden? Sorry.
Yeah, so we'd have to dig a trench and lay the cable in it. Luckily, the people from the tea garden did most of the digging, which was the hard part. Yeah.
And is that like, could you like continue collecting data from that? Is it continuous, or do you have to like deploy cables every often?
No, so these were instruments that we're putting out, and we had hoped to put them out for several days at a time, and then take them back. And so we were leapfrogging, putting out instruments and then picking them up and moving them elsewhere, and then we all had to go back to the US at the end.
Okay, that makes sense. Also just wondering, like, since we're in the topic of tea gardens, we are seeing a lot of risks related to tea gardens because of climate change, how because of shortage of rainfall, tea production is less, in addition to like other climate change factors. So what risk could earthquake pose to these tea gardens, or if there are any risks from earthquakes at all?
There are large, risks from earthquakes. I don't know if that the tea gardens are the highest risk from the earthquakes, but we've seen in earthquakes in Sylhet some liquefaction in the valleys between the tea gardens. And I think, the biggest threat is the cities and the buildings are not, are mostly not built to withstand a large earthquake. And because the sediments are very soft in Bangladesh, there's a chance of the shaking getting amplified and becoming larger.
And that would be same for both the cities, where, of course, because of the buildings, the risk is larger, but also for tea gardens, which are tectonically active.
Right. Although what we've seen is that on the hills, the shaking is less than in the valleys.
Okay, and is there a reason for that, or?
Yeah, I mean, it's really the harder ground of the hills that the tea gardens are on versus the softer sediments in the valleys. And
do you also think there could be some geographical changes to the tea gardens, because there were geographical changes because of the Assam earthquake where rivers were rearranged?
Yeah, I think less so for the tea gardens, but rivers certainly can be arranged, and we have found a couple of locations in Bangladesh where we think an earthquake has caused a river to shift. We have one farther south in the delta where we think 2,500 years ago the Ganges River used to be, and caused the avulsion of the river farther to the west. And then I've worked on a place near Brahmaputra where we think there was an earthquake that shifted the Meghna River.
Oh, and how long was that?
Not completely sure. It could be as much as 3,500 years ago, so quite a long time ago, but the river might have shifted by 20 kilometers.
Okay, and like also if we have a 7 magnitude earthquake in the future, there's a chance for these rivers to also shift.
Yes, because if there's a large earthquake, with a 7 or something with an 8, and you have several meters of land being uplifted, that's enough to shift a river because the topography is so flat.
Yeah, and if I'm not mistaken, I think during the Assam earthquake, that's when Saint Martin Island, shifted and like came up and became visible.
Not really, so during the 1762 earthquake, we found that it uplifted St. Martin's Island by about 2.5 meters. But what I've seen is that it looks like St. Martin's Island was not populated before that earthquake. So the uplift of the earthquake probably enabled it to create a freshwater lens, to have fresh water on that island, whereas before the earthquake they may not have been.
That's very interesting to know. And I also think that we see Bangladesh in the news because of the impacts of climate change that it's going through, and one of them is like increased river erosion. And how would shifting courses of these rivers, would it increase river erosion, or like just in general, what impact climate change might have?
With climate change, actually, compared to many deltas that are sinking, Bangladesh is in better shape. It's actually, there is still so much sediment coming down the rivers that Bangladesh is net still gaining land. Of course, the gain of land is mostly around the Meghna River in the river mouth, whereas farther west in the southwest is not receiving enough sediments and is losing land and subsiding, and there are lots of problems with waterlogging in the southwest. But with climate change now we have sea level rising, but at the same time the increase in the monsoon may bring down more sediments and help compensate. So for that.
Yeah, I think when we talk about a country being climate vulnerable, we also don't compare it to similar geographically situated areas, and I think that's a very interesting thing you were mentioning, how it's gaining land. And so I think, and the gaining of land, those are like, that they appear because of sediments, that's from the Himalayas, right?
Yes.
And these are the ones that we call chores.
Right.
And I know you take your students to the trip to chores and to do surveys. Our class couldn't go because of the pandemic, but I know you went last year, and I'd love to know about that experience and if you went to chores.
Yes, so, I mean, we went to chores certainly on the, in the Brahmaputra River, where the islands are always shifting around within the river. But we also went to Bird and Egg Island, which is just offshore of the Sundarbans.
Yeah.
And that's, I think that island is probably now about 30 to 40 years old, and so it's grown up, and it's a great place where you can see, because the island will come up with just sand, and then grass, and then bushes and trees and falling mangroves, and you can see that all of those on that one island.
Wow. And then you also go to the Sundarbans.
Yes, we also spent time in the Sundarbans.
Yeah, and how was the last year's trip? I have seen pictures and they look amazing.
It was a really good trip, and the students actually did a lot of interviews with the local people, and one of the groups has actually written that up for publication.
That sounds really good. I'll be sure to read that when it comes out. Yes. So you have worked in many different places, including, like you mentioned before, Turkey and other countries. And so I was wondering, why Sylhet?
Okay, well, Sylhet, even within Bangladesh, is a very special place because it's a place where essentially 3 different plates in the world are overlapping. So there's the Asian plate, there's the Indian plate, which is colliding with Asia and forms the Himalayas, and we think that Meghalaya, which we call the Shillong Massif, is actually the beginning of a forward jump of the Himalayas, and at the front of that there's a thrust called the Deltaic fault that's thrusting over Sylhet. At the same time, we have the Indo-Burman ranges, which is part of that subduction zone coming from the east, from the Myanmar or Burma plate. And so between the Indian, Asian, and Burmese plates are all intersecting and overlapping in that area with several different fault systems.
And that's why it's a mega thrust and has, creating such a high energy earthquake. And also, it's not only that Sylhet or Bangladesh is in risk, but also the surrounding areas, including Assam in India or like Shillong, those also, are in the potential risk zone for earthquake.
Yes, so, the fault extends under Bangladesh, but it also extends then into northeast India, and would affect Myanmar as well. So it's a regional area, and so we've worked in all of the countries around Bangladesh as well as Bangladesh as well.
But your main field area is?
My main field area has been Bangladesh.
And how do you collaborate with other scientists who are working actively on, let's say, Shillong or northeast India on these plate boundaries and earthquakes?
Some of my colleagues have gone and worked and mapped some of the faults and the tectonics in the other areas. We are collaborating with people in the other countries as well, the same way I do with multiple universities, especially Dhaka University and now Bangladesh Open University in Bangladesh.
What do you measure earthquakes with, or the movement of tectonic plates with? And has that measuring expanded since you first started working in Bangladesh?
So a lot of what I do is using GPS systems. So the GPS in your phone can perhaps tell you where you are within 10 feet or 20 feet. We have instruments where we can get the position within about 2 millimeters, so a 1/12 of an inch each day, and we've mostly mounted those on solid buildings, and over the years we can watch the land move. And so we can see, for instance, the two parts of the fault moving towards each other and accumulating strain, or we can see the land sinking in the coastal zone of Bangladesh.
That's very impressive. I think it should be a great time-lapse video of like watching what's going on in the earth. And I think you have one of those instruments in Dhaka University, is that true?
Yes, that was one of the first one we installed in 2003 in Dhaka University. It's no longer working, and its view of the sky has been ruined by a new building. But we have them, all over many parts of Bangladesh now. We have also installed temporarily seismometers around Bangladesh. So in Sylhet, we had a deployment. We went from Gazipur to Sylhet, where we put 30 broadband seismometers out for 4 years. It was originally going to be 2 years, but as a result of the pandemic, they ended up staying longer.
And that means you have more data.
Right, but that means we have more data.
Yeah, and do they have to be in specific spaces and geological features, or?
Yeah, so we try to put them in specific geological places to get what we want, and certainly for seismometers, you also need some place that's very quiet if possible, which is very difficult to get away from people in Bangladesh. At the same time, you need them to be secure and safe. And so we've done a variety of different places, including tea gardens. For the GPS systems, I find the roofs of schools are often very good. So I've done a lot of primary schools, especially in the coastal zone, where those buildings are often cyclone shelters. And so the strong reinforced concrete building is exactly what you need for installing a GPS.
So art sciences take such a long time to study, but also to get to results, and then it's still evolving. And so what does the time of the passage of time looks like for you as a scientist?
Well, so for many of the things they do, it takes years to gather enough data to be able to see it. So a lot of the GPS, usually I like at least 5 years of data. And in fact, I'd say early in my career, I was working on things that were millions and tens of millions of years ago, and as time has gone by, I've gone more and more towards what's happening now in real time. But geologists are often used to thinking about deep time that goes back thousands and millions of years ago, because those things have shaped the geology and the surface and the landscape of Bangladesh. And
also there's, I think, a saying in geology that the past will tell us the future.
Yes. So we look to the past earthquakes, past changes in how the rivers have shifted, to try and understand what it might do in the future.
And so I just had kind of, now that we are nearing the end of the podcast, and I know it's so hard to talk about these thousands of years of earthquake history and the future of that in less than 20 or 30 minutes, but I think one question that I wanted to relate science to society is how much of the resources that Bangladesh has, which is very limited, should be delegated for earthquake mitigation, given that one, it's uncertain, and second, there are many more imminent pressing needs.
Right, that's a really important question. We actually published a paper about that. So Bangladesh is facing what's called a wicked problem, in that because the earthquake risk is so uncertain, it's unclear what the correct path is. There is no easy answer. Clearly, an earthquake risk is real, but it may not happen in our lifetimes. Mm-hmm. And so how much resources do you put versus, doing other things? So you can retrofit a school so that it's earthquake resistant and then not be able to afford to have a teacher.
Yeah.
You know, that's obviously counterproductive.
Yeah.
I think, you know, one of the best ways forward is, you know, when you build new buildings, build them earthquake resistant. And, you know, over 100-year time scale, most of the buildings in Dhaka will turn over and be replaced. And that's, you know, a way forward. You know, the same way with building cyclone shelters, you've tremendously reduced the risk of death from cyclones, but it's taken a period of 40 years, and it's going to similarly take decades to do that and reduce the risk from earthquakes in Bangladesh.
Yeah, I think they have prepared really well for cyclones nowadays because the
Yes.
casualties have definitely lowered, but people are more aware, like when to evacuate and
Right.
where to evacuate, and that's been very useful.
Right. And you need the awareness, because if you're going to build a building that's earthquake resistant, it's going to cost 5, 10, 15% more. And so you need to have the people willing to spend that extra amount. And I think that's already starting with sort of some of the wealthier people and more expensive homes, and hopefully with time that will filter down to middle-class homes and on to most of the buildings as they get built. Because you need the pressure from the people and the government to construct homes properly.
Yeah, totally, like with newer building codes that are more earthquake resistant. that I
And
mentioned.
people following the building codes.
Yes, that's another issue.
Right, which
Yeah.
was a big problem in Turkey, was most of the buildings did not follow their building codes.
Yeah, so it needs to have like a proper plan, but then also an effective execution of that plan.
Yes.
And yeah, with that note, we're gonna end our podcast. Thank you so much for being our first guest on the podcast, and explaining earthquake risks in Sylhet and how can we prepare to mitigate that.
Okay. Thank you for having me. I love working in Bangladesh and going there, and so I'm very happy to spend time talking about it.